Hi, I'm Yiannis Kanellopoulos. As you can guess from my name, I come from Greece. I'm the founder of Code for Thought, a technology startup whose goal is to become the synonym of trusted or responsible AI. In my speech, I will explain why it is important for a machine learning model not only to be accurate, but also to be fair, accountable, and transparent. I hope I see you all in my session and we can have some fun together despite the physical distance. I'm a person who favors remote work and digital life, but I do appreciate when developing any kind of relationships in real life. Thank you very much. Good evening. My name is Yiannis Kanellopoulos. I wish I was in Lithuania and presenting this live with everyone. Apologies for my for the scars I bear on my face. I wanted to say that I had a fight with my wife this morning, but this is not true. I had a small surgery a couple of days ago. That's why the stitches. So bear with the view. But the content is way better than the presenter, let's say. So today what I'm going to talk to you is how we can build trust and quality in the era of software 2.0. In other words, what I'm going to talk today is why properties like fairness or accountability and transparency are very important for artificial intelligence / machine learning models. I would use the terms AI / ML interchangeably. So let's start. I'd like to start my presentations either at clients or at conferences with this really nice quote from Yuval Harari. So I was reading his latest book, 21 Lessons for the 21st Century, and I isolated this sentence that says, already today, truth is defined by the top results of the Google search, which makes perfect sense if we all think. And it is really interesting to realize that we are getting more and more prone to follow directions or follow indications or recommendations from algorithmic systems. There is also this well-known incident of a driver following blindly the GPS, although he knew the area he was driving into, and the GPS was directing him towards a cliff. And thankfully, this guy knew the area very well. So last minute, he realized that he was driving his car into a cliff. And of course, he changed his course of driving. But nevertheless, this indicates how we are letting ourselves into the hands of algorithms or systems that they think for us without us. And if we do, let's say, a simple Google search on algorithmic bias or algorithmic fairness, we can be flooded by headlines in the media. What I found very interesting from those headlines is the headline from Machine Bias, which is the famous study from about the Compass recidivism algorithm, that it was giving bigger sentences to black people compared to white people. Or this incident with Apple Card. So when Apple launched their credit card with the help of Goldman Sachs, it turned out that it was biased against women. So if me and my wife we have the same credit profile, then I get twice the credit limit that my wife gets. And that was the whole point in this article, which indicates the importance of us being able to control the algorithms in order to trust them even further and adapt them even further. But it's not only about headlines. What we saw with the recent events of the death of George Floyd in the United States, we saw that technology there played a very historical role. And his death resurfaced the discussions about image recognition and facial recognition technologies, and all this public discourse actually led firms like Microsoft or IBM or Amazon to withdraw their technology and say they won't sell it to police departments because they are afraid of the impact their technology have and the possibility for it to treat certain people of color unfairly. So all those things, they keep us at night. So in our team, which I proudly represent today, we're a team of software engineers, machine learning engineers, researchers, and DevOps engineers. And we've been working for more than overall, we have more than 2 decades of experience of auditing large-scale software systems, and we help corporations to identify the potential risks they bear with those systems and the flaws related to them. All those years, we realized that the flaws of the systems actually, they mirror the organization, they mirror the people that created those systems. And all those systems are the traditional ones, the systems that I like to call software 1.0. And what we see is that the impact of these systems malfunctioning is great, is big. But with the new era of software systems, the software 2.0, which is the AI or machine learning systems, we realize that the impact is even greater, and because they operate at a larger scale and they are at a faster speed. So if something goes wrong, it can go wrong really fast and affecting lots of people. So what our team is doing these days is we build technology that will ensure that AI and machine learning models are fair, accountable, and transparent. Today, I'm going to present you the, let's say, the theory behind our technology, or the reasons that led us to build this kind of technology. And I will conclude with a case study we did when we evaluated the image preview selection algorithm of Twitter and what were the results there. So let's start by defining the software types that I was talking about. So to our view, we have 2 types of software systems: the deterministic ones, which are the code-driven. So you can see that that's on the left side, on the left image, you can see a system where the business logic is hard-coded, is coded into the system. It's fabricated, it's integrated into the system at the source code level. So so if this system makes a decision just by going through the source code and the steps, we can realize how this decision was made. And on the right side of the slide, on the right picture, we can see, let's say, a neural network system. You see lots of nodes with lots of probabilities, with an input and an output, and there we can realize that it is very difficult to interpret or to deduct how a certain decision was made, how the output was made. And we call those systems data-driven because they have way less source code that makes a decision, but they receive way more data that are fed to a model, and the model makes a decision. And of course, I like to use the term software 2.0 that famously was introduced by Andrei Karpathy in 2017 in this Medium article that was posted in 2017. So you can see it here. So today we're going to focus our attention to the software 2.2 systems, the probabilistic ones. And before we do that, let's discuss why do we need probabilistic systems. So one can say, well, if we can code everything, then this is fine. We don't need any AI model or any machine learning model, because we can do everything at the source code level. So, and when I have this kind of discussions, I'd like to show people this image. This is a decision tree that was created using the CAR dataset. It is a public dataset that you can find easily. It is considered to be a very small dataset, actually. So you can see the size of the tree it produces. And imagine if you had to implement this tree just by using if statements or for statements. But this is not the scary factor. The scary factor is try also to maintain and support this decision tree implemented in if statements in the long run. So let's just say that for the next 15 years, you have to maintain and support the code that implements this decision tree. So you understand that this is a mission impossible task, and that is why we need the data-driven system. That is why we need statistical models, AI models, or machine learning models to do some processing for us in a more scalable way. So what defines then whether a model is good or bad? So in the typical software systems, the code-driven ones, we have, let's say, the so-called software quality standards to define the expected behavior of a system at the development level towards the end user level. And it is our view that the software quality is becoming less relevant when it comes to software 2.0 systems, in the sense that there is less code and more data to process. And that is why I would like to say that from software quality, we're moving to AI behavior to cover for the new generation of software systems. Now, if we are to compare what is the state of practice for the code-driven systems compared to data-driven systems, we created this table. So what happens here is that so for instance, for a typical software system, there are several industry standards and certifications to define its quality. A very well-known ISO standard is the ISO 25010 for software product quality. Now, for the data-driven systems, so far we don't have this kind of standards or certifications. Of course, there are several initiatives from IEEE or ISO committees to define those standards, but still they are either at a preview or a draft level or even in the making of the preview. When it comes to formal training and professional certifications, everyone knows about the Oracle Java certification, for instance, or Microsoft .NET certification. There are methodologies like Agile, and there are trainings that you can receive as a software developer in order to be formally certified, but this is not the case yet for data-driven systems. There are several courses in Coursera or Udemy, but there is no, let's say, a large software vendor like Microsoft or like Google or Facebook that says, guys, this is the certification, this is my certification for a data scientist or a machine learning engineer. Still, things exist, but not fully. The same goes for methodologies. I mentioned before Agile. So for software development, we have from back on the old days, we had the waterfall methodologies. Now we are moving towards Agile. There are lots of tools and processes to support all those nice things. They're rather mature when it comes to software engineering, but when it comes to machine learning engineer, we as industry try to adapt the existing ones into the machine learning world and to the machine learning pipelines, let's say, but still we're not there yet. There are several tools and processes that are being made, but so far we don't have, let's say, a state of practice or a state of the art. And same goes for regulations. So for typical systems, we do have lots of regulations and legal requirements prescribing how a system needs to be delivered and what should be the requirements for its acceptance. Nowadays, the same is being created for AI or machine learning models. There are regulations like GDPR, for instance, in Europe that specify how data or automated decision making shall be conducted, but still they are not enforced in the same way that they are enforced, for instance, for the typical software system. An example of a GDPR on how GDPR prescribes certain things and is shown in this slide. So in Article 5 of GDPR, we can see that the lawmakers prescribe that personal data shall be be processed lawfully and fairly in a transparent manner. So here we have the characteristics of the properties of fairness and transparency that are being explicitly mentioned in the GDPR. And also the Article 5 mentioned that the controller, the person responsible for the data, needs to be able to demonstrate how these are compliant and how responsible they are. So that falls into the category of accountability. Those three properties highlighted with orange color, these are the ones we try to cover with our technology at Code for Thought. So fairness, accountability, and transparency, the so-called FACT. We see that those principles have been prescribed in GDPR, but if we start digging more, and I'm not going to do that in this presentation, this is not the goal of this presentation, we see how easy it is to circumvent them or not to enforce them, because there are several loopholes that one can use in order to avoid exhibiting all those properties, let's say, to the regulator, or at least they can not necessarily avoid, but they can partially show that they comply. So going back to the machine learning discussion. So I was reading a study that says that less than 1 out of 3 AI projects are succeeding, and are actually the models are being deployed into production. There are 3 reasons. First of all, in certain cases, we don't choose the right solution for the right problem. In my experience, I see companies either building a cannon to kill a fly, or really not taking the problem seriously into account. So the solution was not up to par for solving a given problem. The second challenge one needs to face is to find the proper training dataset, which is a problem that several companies are trying to solve. And the third problem, which is the one our team is focusing there, is the lack of trust. People do not trust a model in order to deploy it successfully to production. And by deep diving on the last, on the third bullet, we identify the 3 subsequent challenges. First of all is that the technical teams do strive for accuracy and fast delivery. So fairness or accountability or anything are afterthoughts. So they don't care of building trust. They care to deliver something that works and solves the problem set by the business side of an organization. And also, when one is trying to impose trust, this is usually being done for regulatory purposes, and it's being done in an ad hoc and one-off solution, just to show to the regulator that we do something for compliance and people can trust us, but not they don't go for a sustainable or a more permanent solution to do so. We believe that the so-called FACT properties, fairness, accountability, transparency, are very important, are of paramount importance for building trust towards an AI or machine learning model. We have some tips, let's say, on how we can use them. The first tip is that if you want to build trust, try to be simple but not simplistic. So you don't need to show to your users or your clients or your stakeholders a ton of metrics, 1,000 different metrics that attest that your model is fair. Just try to select a couple of them that they really work and they are essential. So to give them just the basic picture or the big picture. Be transparent but selective. You don't have to show them everything, but you have to show them the essence of the information they need in order to be able to grasp what your model does and understand it and then trust it. And it helps if you try to use, when you do that, you do your analysis, if it is based on references or standards or checklists, this helps towards establishing a certain credibility for your analysis and for your and credibility in your endeavor to build trust for your model. Now, we strongly believe that those properties can be checked and can be part of a machine learning pipeline. And in this slide, we can see, let's say, a typical pipeline for deploying an AI model into production. So we can see that when we train the model at that stage, we can do an analysis and see whether there is bias on statistical bias on the training data. So in that way, we can let's say ensure that we don't instill bias on our model from the training stage. When we finalize training, we can evaluate the same. We can check again regarding bias at the model level, and also we can deploy some interpretation mechanisms and methods in order to understand how our model thinks and how it behaves. And as soon as we do that, and we are fine with everything, and also the engineering team says that, okay, the model is fine, it's accurate, we can deploy it. So as soon as everyone checks the model and it can be deployed, then during production, we can constantly monitor our model for bias, and we can constantly generate explanations for the decisions our model makes in order to be able to control it at all time. In previous slides, I talked about, let me guide you through a little bit on what we mean by fairness or accountability and transparency. So in previous slide, I talked about be simple but not simplistic. So there is a plethora of tools for assessing the fairness of a model. A couple of examples are AI Fairness 360, IKITAS. There was this interesting workshop, the 21 fairness definitions and their politics. So long story short here is that fairness is a philosophical term. I mean, if you and the semantics of fairness change from culture to culture or from language to language. So if we try to assess fairness per se, this is becoming a very subjective term and not easy to objectively measure it. But if we talk about bias, which is a manifestation of fairness, let's say, there are concrete and objective ways to measure it. And this is what we at Code for Thought we chose to do. So we use disparate impact ratio in order to measure bias either at the data level or at the model level during training or during deployment. And this is also well connected. This is also the disparate impact ratio. It is connected with a well-known regulatory rule, the 4/5 rule, which has been introduced in the United States in the Committee for Employment. And what is a 4/5 rule indicate? It indicates that a selection rate for any race, or sex or ethnic group, which is considered to be the weak race or the weak sex, it should be more than the 4/5, more than 80% of the rate of the group, which is considered to be the privileged one. So, for instance, a white male can be considered the privileged group compared to a white woman or a black woman. So the decisions that affect the weakest groups need to be less than 80%, more than 80% of the rate of compared to the rate for the strongest group. So And if we go to see in this picture, what we see is that how we our team as a team monitor the fairness of basically model throughout times through time, and we can see two things. We can monitor the disparate impact ratio for the model overall, but also we can monitor the disparate ratio per cohort, per batch of data that we receive. So in the orange line, you can see how the trend is for the overall model, and in the spike line, the blue line, you can see how each cohort of the data our model receives is behaving in relation to the disparate impact ratio. So what you can see is that this particular model that we see here is not fair, because constantly the disparate impact ratio, the value for the value for the disparate impact ratio is below 0.8 or and 1.20. So in this area of between 0.8 and 1.2, this is the desired area for our for the disparate ratio impact to be, and this is the nice thing for this particular metric, because we have an industry standard that says price the value should be between 0.8 or 1.2. So everything below that or above the 1.2 is considered less fair or not fair as a value. And when we say about sensitive attributes, according to legislations, we have race, sex, age, and so on. This is what is depicted in this picture. So in this slide, sorry. Of course, there are cases that the legislations do forbid companies or banks to use sensitive attributes in their models, but we have the other problem, the so-called approximation problem, which is we use proxies, and actually those proxies still propagate bias. And we have the well-known redlining case. So in the United States, they were not using the sex or the color of or the ethnicity of for the clients of a given bank, but they were using their zip codes, and there are several blocks that are being inhabited by people of color only, and not white people. So the zip code was an approximation actually for the color and the race, and it was and again it was creating bias, and it was infiltrating bias in the model's decision. This is about fairness. Now, when it comes to accountability, our view is that when we talk about accountability, this concerns both the organizations that they design or cater for algorithmic systems or AI systems, and the models. So in order to make sure that the model is accountable, we need, first of all, to set the proper processes at organizational level. And then at the technical level, the team needs to, the engineering team needs to take into account several aspects during the creation of the model, and not after the creation or the deployment of the model. And in this example, this is we saw how a checklist helps an organization in the self-assessment that they do. So in this, we have also the link for a couple of articles we wrote that they describe this particular exercise that we did. So by using checklists and for self-assessment within organizations, for in both sides, organizational level and technical level, we can help teams identify their weaknesses. So in this particular case, we had a team that were using an unsupervised model for solving a particular problem, but without being able to check regarding the ground truth and plus the training of that model. They didn't have the proper annotations, so it was very difficult for them to say whether the model is accurate or not, and how it behaves when it comes to fairness, let alone the fact that they were considering that the auditability of the model and the fairness of the model were not important for its deployment. And actually, this model was flagging the employees of large corporations as susceptible for information leakage or not. So a model that actually was judging an employee's behavior. The team that was building it wasn't thinking that fairness or the ability to audit the model are important for its deployment. Now we need transparency. This is the third property. We talked about fairness. We talked about accountability. Transparency is the third one. So we need explanations to not only to understand how a model works, but also to scrutinize the model and see whether there is a systemic bias. So this is an example presented in another paper that we wrote with our team, and here we see that in the left picture, an image of somebody that was rightfully was predicted as male, but on the right picture we see the singer of Green Day, who was classified by a model as a female because you can see that the eyeliner and the makeup in his eyes contributed towards him being classified as a woman. And by using the explanations, we can see the weaknesses of our model when it comes to bias, and then we can fine-tune the training of a model, and we can cater for cases like this one. So all this is good. One can ask, so where did you apply your model? So of course we have some client projects that we know there is some sensitive information, so we're not allowed to. So what we decided to do with our team is that when this Twitter AI bias controversy started, so there was this famous tweet by a user that the Twitter's photo preview selection algorithm was presenting only Mitch McConnell and not Barack Obama in the pre-selection. So there was all this public discourse saying that okay, this is bias. This is the algorithm is not working correctly. So Twitter said, well, we did test our algorithm for bias and we didn't find any issues there. So what we did in our team, we created a data set. Ourselves with images of black and or of white people and people of color, not only black but people of color in general. We made sure that this is a balanced data set, so each group of an ethnicity is more or less equally represented in the data set. So we created, so all those photo collages that we created, we started feeding in a Twitter account that the Twitter made available, and that's, we have to say this, that Twitter was very fast responding in this public discourse, saying that they will create an account in order for people to test the algorithm, scrutinize it, and see if it's indeed biased or not. The only restriction that it was having was that it could receive only 300 tweets every 3 hours. So that is why we use approximately 8,000 images for our experiment, for our analysis. So we did upload those pictures, and we have done a manual labeling whether the preview is black or white, or people of color or white. So we got the results based on the manual label that we did. We conducted our fairness analysis, and based on that analysis, then we fed all the 8,000 single photos. So they deducted from the 4,000 photo collages that we did, and we tried to explain why certain pictures were selected by the algorithm and what has caused that. So an example of the transparency analysis you can see here. So we were showing that we had in the left picture we saw why a white person was selected compared to a person of color, and in the second picture we saw the pixels, the green pixels indicate why a person of color was selected compared to a white person, and so the green pixels were they were the ones indicating the positive contribution in order to select somebody as a white, and the negative contribution, the red ones, the negative contribution for selecting somebody as a person of color. So these are the visualizations we created, and what our analysis showed, and it was the graph I showed you some slides before. Let me revisit it. So our analysis showed that the algorithm was indeed biased. So whenever we had he had to choose between a black person and a white person, the algorithm was going for the white person. But one then can say easily that, okay, there is ethnic bias, so the algorithm is biased against people of color or black people. So what actually happened is that we decided to think behind the obvious, and we did an analysis of the quality of the images that we analyzed for fairness. So what happened is that what we realized is that the algorithm was not choosing based on ethnicity. That was an image classification algorithm that was choosing, and the most important thing for the choice was the sharpness of the image. So there was a strong correlation between the people of white color to the images. Those images had they were sharper compared to the images with people of color, and that is why the algorithm was selecting those pictures. So it wasn't let's say an ethical bias or racial bias. It was mostly a technical bias. For those more interested to read, we also wrote an article. It's on our website, and it's on our Code for Thought Medium account. So you can visit there or contact me to send you the link. So that was it for me. If I have to close the discussion, I'd say that the conclusions from what we discussed today is that Software 2.0 AI can impact our lives at scale and at unprecedented speed, so very fast and very crucially. So it is paramount for us to be able to trust those systems. We can use technology to control technology. We like to call it also, we can use AI to control AI. The most crucial factor here is the people who are going to be using the technology to control the technology. So how we can augment, how we can empower those humans with the task to control technology. And we need the blend between the human and the technology, because as you can see in the Twitter case, you need to think critically. You need to challenge your analysis, to challenge your results, and try to think deeper. So for us, it was easy to say, well, there is bias, and this is ethnical bias, and which will give more headlines and more publicity. But you have to dig a little bit deeper. You have to think a little bit more constructive, and that is why a human is needed in order to be control effectively an AI model. And last but not least, the domain of building trust over a machine learning model is a great opportunity for jobs creation, and actually it can be the catalyst for the jobs of the future. So imagine a future where a profession would be AI validator, or AI explainer, or AI controller. So These are the things from my side. These are my contact details. You can email me at Yiannis@codeforthought.eu, or you can follow our Code for Thought account. Yeah, now it's time to see if there are questions. I see there is already a couple of them. So yeah, the question is that if I can mention a case where FAT properties were not applied. I would say that all those headlines that I showed in the beginning of the presentation, there are typical cases where an organization is not applying the FAT properties. They treat them as either afterthoughts or they're not considering them at all. From our in this project that we did with and I talked about the account when I was showing the accountability checklist, the impact there was that of course fairness and transparency were an afterthought there. The good thing is that we did this analysis before the model has been deployed, so we managed to avoid the risk of either bad publicity or problems with employees or things that actually can create can damage the relationship between a company and their employees. But I would say let's say nowadays, if large corporations are not paying attention to those type of properties, then it's easy to be in the headlines, and that means bad publicity. Sometimes, but of course, sometimes, of course, mass media one can say they can exaggerate, which may be true, but nevertheless, and this is very encouraging. Nowadays, more and more companies and people and citizens are becoming more aware of the impact that algorithmic decision making is having in our lives, and they try to cater for that more and more. This is it from me. I'd like to thank everyone for your participation, your questions. Yeah, so I think I can answer one more question that just can't. This is a very good question. I read it first. So let's assume that men have a higher risk in car accidents. Would it be appropriate to include gender in the model so that insurance would be cheaper for women? This is a very. I was reading an article about it a week ago with exactly using this this example. So there is a contradiction. One can say that if we incorporate this information to our model that men have a higher risk for accidents, then it can make pricing for women. If we don't do that, then women and men are equally sharing, let's say, the risk. But if we do that, then our model actually gives less insurance premium to women. I think in several cases we need, as an organization, needs to make a conscious choice. So what I was also trying to say today is that trying to create a bias-free model or models that are totally fair is almost a mission impossible. The most important thing, though, is to make conscious decisions about what we choose and what we try to optimize when it comes to fairness. And those choices need to be reflected and documented in our policies and models. I would say that if an insurance company says, I'm going to equally distribute the risk between men and women, and that's my business decision, nobody would say this is necessarily wrong. But on the other hand, if they say, well, we're going to give men higher insurance premiums for their because we classify them as more dangerous, let's say, then again, this is a business decision and is not necessarily wrong. But these things need to be documented. These things need to be there need to be conscious choices. So then the clients of a particular organization need to know how this organization makes a decision, and then they decide. So again, thank you very much. I hope I'll see you later. And yeah, take care. Bye.